Hello everyone. So today we'll be looking at this problem from the mathematics section of CSIS, which is called exponentiation. So the problem states that we have to efficiently calculate values of a bar b modulo this value, that is 10 power 9 plus 7. So first I'll just define my modulo with the value that I'm taking. So it is, let me just define it as const ll mod equal to 1 9 plus 7. Okay. Let me just define LL as long. Okay. So now what's the difficulty in calculating A bar B? So see, if I just follow a simpler algorithm that let me just go through a loop and let me just write this loop, something like this, that I'll simply keep on multiplying. I'll take some result as A and I'll just keep on multiplying result equal to result into A, and I'll just keep on taking modulo at every step, and I'll print the result. This works, right? There's nothing wrong in this method. I can just take two inputs of A and B, and I'll take input A and B, and I'll do this, which is completely fine. But what's wrong with this? That is in the constraints of the problem. So the problem says that the constraints of n are some 1 to 2 and 10 power 5. So n is the number of queries that we have, right? So the problem is somewhat like this, that you will have n queries, and in each query you will have some value of A, some value of B, and you have to give me what is the value of A bar B. So problem is that the limits of A and B are 10 power 9. So if I follow this kind of a method, I will have to, like, this single loop would take the complexity of this part is O of B, right? Is O of B, and if I do this for n different queries, so the complexity would be O of n into B. So the problem is time complexity, or TC, is going to be O of n into B. So you can very well see that the limits of n is 2 into 10 power 5 and this 10 power 9, so it's even greater than 10 power 40, right? So definitely we can't implement this, right? So we need a much simpler method. So what about this idea that we calculate these powers much more efficiently than what we're doing this time? Now we are doing it in O of B. Let's improve that, right? Okay. So to improve this, we have this idea called modular exponentiation, or what we call as binary exponentiation, right? So what is this idea about? I'll just show you an example. So let's say we're calculating, let's say 2 bar 10, right? So if you're calculating 2 bar 10, we could just multiply 2 10 times, and that would take 10 iterations. But can we do it in lesser number of iterations, right? So one single idea is that, can we visualize how to write 10 in binary? So it is 1010, right? Those of you don't know how to convert it, you can just look some video how to convert from decimal to binary, but that's the way of doing it, right? So the idea is that we will break it into lesser powers. So what we will try to do is, now see, we are doing it for 10 times as the power is 10. Now if I can break it into lesser powers, like if the power was 5, so I would be able to reduce the time. If the power was 2, I would be able to reduce the time even further. So the idea is that I'll write 2 power 10 this way, that 2 power 5 and square of that, right? Or I can write it as 2 square to the power 5. Either of them is okay, right? So so what we'll do is we will keep dividing that. We'll keep dividing that in powers of 2. That's why we are calling it binary exponentiation, right? So can you see it, that I can write it this way? The same thing could be written as 4 to the power 5, and the same thing could be written as, now see, now it is an odd power, so now 5 is not divisible by 2. So I could just write it this way, that this is 4 into 4 power 4, and 4 power 4 could be further broken down into 4 square ka square, which is 16 square, which is 16 square, right? And now again I can make 16 square as 256, right? I can again convert this into something like 4 into 256. So can you see that I've reduced the number of iterations by such a greater extent? So what I'm seeing is, whenever I have an even power like 10, right, I can simply divide the power by 2 and I can square the base. And whenever I have an odd power like 5, I have to take the base, I have to multiply the base once, and then the rest of it, like whatever is that b by 2, I'll simply change that to the new power, and the base will again be squared, right? So if I try to implement this function, let's implement this here. So I'll return ll, let's name the function as power, and I'll take two inputs, one is lla and one is llb. Okay, and I'll take some result. So let's take result equal to 1. So now what I'll do is, while my b is greater than 0, because see what happened here is that after this step, right? After this step, your b started becoming 0, right? So while my b is greater than 0, what am I doing? My idea is that if my b module 2 is equal to 1, that is if my b is odd, what I do is I simply take my result and I make it result into a modulo m. And if that is not the case, okay, and something that happens along with this, so I store it in the result, right? And I also do some change to the bases, right? And like my power, that increases by 1, because see I had 4 to the power 5 and I reduced that to 4 into like 4 power 4. So my power just got reduced by 1, and now I can again reduce that. So my power will just get reduced by 1. So b minus equal to 1. And if that is not the case, if it is divisible, so else part will simply divide the power by 2. That will simply divide the power by 2. And what happens? My base is being squared, right? So how will I square my base? What's my base? That is a. So I will simply store a equal to a into a, and I'll take modulo of it, right? Okay. So okay, I forgot to define my modulo. So I'll just take const mod equal to, okay, sorry. I defined it, just did it in the wrong place. Let's just copy it here. Okay, so this should be working. Let me just comment this out. And what will I see out? I'll see out power of a comma b. So that should be okay. And I'll run these test cases one by one. Let me just check for one single test case and then I'll try for the others. I hope this is okay. Okay, I forgot one thing. I should be able to return my result. Okay, let's take this test case. Okay, it gives an error. Okay, I have written m, that should be mod. I hope there are no more errors in this. So let me just run this test case, 123 and 123. And my answer is 921. Yeah, so that matches. So now I can run it for n loops. Okay, I think I should make this ll, and intent, take input, and I will do this for n such cases. Okay, fine. So now I'll just give this particular input and I'll check if the code is working Okay. Yeah, so our code is 81 256 and 9214500552. So this code is working, which means the solution is okay. So I hope you understood the problem. Thank you. You can write your doubts in the comments.